Article 334.80 of the National Electrical Code addresses specific conditions regarding the ampacity of conductors and overcurrent protection. This article is crucial when the ampacity of a conductor, such as a 6/3 with ground cable rated at 60 degrees Celsius, is lower than the rating of the overcurrent protective device, such as a 65 amps breaker. Article 334.80 permits the use of a conductor with a lower ampacity than that required by the overcurrent protection device, provided several conditions are met. Firstly, the conductor must be protected by the overcurrent protection device. This means the breaker or fuse must trip or blow before the conductor's ampacity is exceeded, preventing overheating and potential fire hazards. Secondly, the raceway or enclosure housing the conductor must have a temperature rating suitable for the ampacity of the conductor. This is critical because the heat generated by the conductor can raise the temperature within the raceway or enclosure. If the enclosure is not rated to handle this temperature, it could degrade, leading to insulation breakdown and other safety issues. For example, a 6/3 with ground cable, which is typically rated for 55 amps at 60 degrees Celsius, is being used with a 65 amps overcurrent protection device. In this scenario, the enclosure or raceway must be rated to handle the heat generated by a 65 amps current. If the enclosure is only rated for, say, 60 amps, then it does not meet the requirements of Article 334.80 and a larger conductor must be used. The relevant table for determining conductor ampacity is National Electrical Code Table 310.16. This table provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current carrying conductors in a raceway or cable or earth directly buried, based on ambient temperature of 30 degrees Celsius. Correction factors apply for ambient temperatures other than 30 degrees Celsius. To properly apply Article 334.80, firstly, determine the required ampacity based on the load. Secondly, select an overcurrent protection device that is sized appropriately for the load. Thirdly, choose a conductor with an ampacity that is less than or equal to the overcurrent protection device but greater than or equal to the load. Fourthly, ensure that the raceway or enclosure is rated for the ampacity of the overcurrent protection device. If the raceway or enclosure is not rated for the required ampacity, a larger conductor must be used. For example, suppose a subpill requires a 60 amps feeder. You might consider using a 6/3 with ground cable, which has an ampacity of 55 amps at 60 degrees Celsius. However, if the overcurrent protection device is a 65 amps breaker, Article 334.80 would come into play. To comply with Article 334.80, firstly, ensure the 65 amps breaker is protecting the 6/3 with ground cable. Secondly, verify that the enclosure housing the cable is rated for at least 65 amps. If the enclosure is not rated for 65 amps, then you would need to use a larger conductor that has an ampacity of at least 65 amps, or use an enclosure that is rated for 65 amps. It's important to consult the National Electrical Code for the specific requirements and any applicable exceptions. The code provides detailed guidelines and tables to ensure electrical installations are safe and compliant. Always refer to the latest edition of the National Electrical Code, as requirements can change over time. For example, if you are running a 6/3 with ground cable to a subpanel in the same structure, the cable's ampacity must be sufficient for the load it will carry. If the cable is only rated for 55 amps at 60 degrees Celsius, but the overcurrent protection is set at 65 amps, you must ensure that the installation complies with Article 334.80. The critical factor is the temperature rating of the enclosure or raceway. If it's not rated for 65 amps, you'll need to increase the conductor size to one that can handle 65 amps or reduce the overcurrent protection to 55 amps or less, provided that it is sufficient for the load. Another consideration is ambient temperature. Table 310.16 in the National Electrical Code provides ampacities based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher, you must apply correction factors to reduce the allowable ampacity of the conductor. For example, if the ambient temperature is 40 degrees Celsius, you would need to apply a correction factor from the table, which would further reduce the 55 amps ampacity of the 6/3 with ground cable. This could necessitate using an even larger conductor or reducing the overcurrent protection. Furthermore, the type of terminations used with the conductor must be considered. Some equipment is only rated for 60 degrees Celsius terminations, which means you must use the 60 degrees Celsius ampacity rating of the conductor, regardless of its insulation temperature rating. Other equipment may be rated for 75 degrees Celsius or 90 degrees Celsius terminations, allowing you to use the higher ampacity ratings of the conductor, provided the conductor's insulation is also rated for that temperature. In summary, Article 334.80 of the National Electrical Code allows for flexibility in conductor sizing, but it requires careful consideration of several factors, including the ampacity of the conductor, the rating of the overcurrent protection device, the temperature rating of the enclosure or raceway, the ambient temperature, and the type of terminations used. Always consult the National Electrical Code and a qualified electrician to ensure that your electrical installations are safe and compliant. For example, if you are installing a subpanel in a residential setting, you need to carefully consider the load that the subpanel will serve. This will determine the required ampacity of the feeder conductors. If the load is relatively small, you may be able to use a smaller conductor size. However, if the load is larger, you may need to use a larger conductor size. In addition to the load, you also need to consider the distance from the main panel to the subpanel. The longer the distance, the greater the voltage drop. Voltage drop can cause lights to dim and appliances to not function properly. To minimize voltage drop, you may need to use a larger conductor size. Once you have determined the required conductor size, you need to select an overcurrent protection device that is sized appropriately. The overcurrent protection device should be sized to protect the conductors from overload. If the overcurrent protection device is too large, it will not protect the conductors, and they could overheat and cause a fire. If the overcurrent protection device is too small, it will trip unnecessarily, which can be a nuisance. After you have selected the overcurrent protection device, you need to install the conductors in a raceway or enclosure that is rated for the ampacity of the conductors. The raceway or enclosure will protect the conductors from physical damage and prevent them from overheating. The raceway or enclosure should be properly grounded to prevent electric shock. Finally, you need to connect the conductors to the main panel and the subpanel. Make sure that all connections are tight and secure. Loose connections can cause arcing and overheating, which can lead to a fire. Always follow the National Electrical Code and local codes when installing electrical wiring. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Electrical work can be dangerous, and it is important to take all necessary precautions. Remember that the 6/3 with ground cable mentioned typically refers to cable containing 3 conductors, each of size number 6 American wire gauge, and a grounding conductor. The ampacity of this cable depends on the insulation type and temperature rating, as per National Electrical Code Table 310.16. Commonly, with 60 degrees Celsius insulation, it's rated for 55 amps, while with 75 degrees Celsius insulation, it might be rated higher, such as 65 amps or even 75 amps. The 60 degrees Celsius rating is often the limiting factor because terminations at breakers and equipment might be only rated for 60 degrees Celsius. To reiterate, when applying Article 334.80, firstly, calculate the load and determine the minimum required ampacity for the circuit. Secondly, select an overcurrent protection device that is appropriate for the load and complies with National Electrical Code requirements for conductor protection. Thirdly, choose a conductor that has an ampacity equal to or greater than the load and is protected by the selected overcurrent protection device. Fourthly, ensure that the temperature rating of the terminations and connected equipment is compatible with the conductor's ampacity rating. Fifthly, verify that the raceway or enclosure is suitable for the conductor and any associated heat dissipation. Sixthly, consider ambient temperature and apply any necessary correction factors to the conductor's ampacity rating. Seventhly, ensure all work complies with the latest edition of the National Electrical Code and local electrical codes. Finally, consult with a qualified electrician if you have any questions or concerns. Consider a specific example to reinforce understanding. Imagine a detached garage that will have a sub-panel powered from the main house panel. The calculated load for the garage sub-panel is 40 amps. The electrician chooses to use a 6/3 with ground copper cable. Assuming the terminations are only rated for 60 degrees Celsius, the cable is limited to 55 amps ampacity per National Electrical Code Table 310.16. The electrician wants to use a 50 amps breaker for overcurrent protection. This is acceptable because the breaker is sized to protect the 55 amps cable and it's greater than the 40 amps load. Also, the electrician verifies that the conduit and junction boxes are rated for at least 60 degrees Celsius. Another example would be if the calculated load was 50 amps and the electrician still uses a 6/3 copper cable at 60 degrees Celsius. If they want to use a 60 amps breaker, this would violate National Electrical Code Article 334.80. A larger cable with a higher ampacity will have to be selected, such as a number 4 copper conductor with a 70 amps ampacity at 75 degrees Celsius. As a final consideration, it is important to note that the National Electrical Code is updated regularly, so it is always best to consult the latest edition of the code to ensure compliance.